So Terrence Howard has this calculator thing that he says shows this loop that shouldn't be possible. And it's actually just basic algebra. He says if you take the square root of 2 square root, it's 1.414. Then you cube it to the third power, and it's 2.8. Then you divide it by 2 and you get back to where you started. Let's look at the math behind that and why it's just, again, basic geometry. I'm sorry, basic algebra. If you take the first part of what he's saying, square root of 2, and you cube it, that's the same as 2 times 2 times 2. Square root of 2 times 2 times 2. We could have it separately, or we could have it together. And he says then you divide it by 2, and now these are not equal anymore, and that it comes back and becomes square root of 2 again. Well, why is that? Because those who know how square roots work, when there are 2, we take it out. So it's really 2 square root of 2 over 2. Those cancel. So root 2 is equal to root 2. This would happen with any thing you cube and divide by itself, by the same number. So if you take 3 and you cube it, it's the same as 3 times 3 times 3. And then you divide it by 3, you're going to get cube root of 3 again. Because again, these two come out, and you're just dividing out the whole numbers. With square roots, we're talking about the sides of a square. So when you have 9, 3 times 3 is 9, your square root is the root of one side. So the square root of 9 is 3. You could use pretty much any number. 5, cube it, which is 5 times 5 times 5. Divide it by 5. These will cancel, and you get square root of 5. Once I divide it by 5, these are not equal anymore. A user pointed that out. Thank you very much. You're basically saying if I take the square root of x and I cube it, then I take that and divide it by itself, by x, I'm going to get square root of x. Yes, of course, because square root of x to the third power means square root of x, square root of x, square root of x, and two of them become a whole number. So you really just have square root of x. Let's look at it as exponents. We can do square roots as exponents. 2 to the 1/2 is the square root of 2 written differently. Then we cube it, and we get 2 to the 3/2. Well, when we then divide it by 2, those who learned how exponents work, we subtract the exponents when we're dividing. This becomes 2 to the 3/2 minus 1, which is the same as 2 over 2. So you have back to 2 to the 1/2, or square root of 2. 2 to the 3/2 over 2 to the 1. We could even change this. It's the same as 2 to the 1 times 2 to the 1/2. And again, the 2 to the 1 cancels out. So it's really basic algebra and how square roots work. Another thing he mentions is that if you take, this shouldn't be possible, because if you cube x and then divide it by 2, you shouldn't be able to get x. And that's also math. The basic algebra would have us multiply on both sides. X cubed equals 2x. We can subtract. X cubed minus 2x equals 0. This is a very solvable problem. We factor out an x. X equals 0, because if we cube 0 and then divide it by 0, 0, well, actually that won't work. 0 you can't divide by 0 unless you're going to use a derivative. Then we take this, x squared minus 2, and we set it to 0. We add 2. X squared is 2. Square root both sides. X is plus or minus square root of 2. If we plug this in, square root of 2 works, but the negative square root of 2 does not, because when you cube a square root that's negative, it stays negative. Anyhow, I seem to, I don't know, it maybe looks magical because it's math some people don't understand, but that calculator trick is really just basic mathematics working. Really what he's saying though, if you want to do it algebraically, you're saying if I take the square root of x and cube it, and then divide it by x, so the x would be 2, square root of 2 cubed divided by 2, it'll equal square root of x. We can even show that that's true algebraically as well. We can multiply both sides by x, and cube root of x equals x times square root of x. The cube root of x is x times x times x. We take out x, and this is a true statement. It's just manipulating the square roots and the way square roots work. I mean, if anything, I'm glad this brings attention to math. Math is fascinating. Even the flower of life is fascinating. The flower of life and the seed of life contain the basic principles of how we replicated geometric shapes. I'll put a video in the description on that. It's really quite amazing. Take the number square root of 2. When you have a square whose sides are 1 and 1, this diagonal is the square root of 2. We can prove that with the Pythagorean theorem. And 1 plus 1 equals x squared. X equals square root of 2. So square root of 2 is a number that repeats infinitely, but we can draw it. We can represent it as a ratio or a proportion of the diagonal of the square compared to its sides. It's a little bit like the circle. The number pi is 3.141 and it goes forever. We can't ever finish writing the number, but we can represent it geometrically. We can draw a circle and we can draw the diameter. The distance around the circle divided by the diameter is where we get the number pi. So what this is saying is, if this diameter is 1, 3.1 of them will fit around the circle, 3.141, and it's something we can represent as a ratio, but we can't ever write down as a rational number.